All right, good evening and welcome to our final Zoom session for Survey of Contemporary Mathematics. This week we're going to be focusing on Chapter 12, which involves geometry. This will be a good week to review lots of geometry formulas, and we'll try to go over some that will be important to us as we tackle the apply this week. The problems that we're going to look at are coming from your textbook. We'll be looking at the end of the chapter review from chapter 12. These will be pages 581 and 582. If you have your textbook, you might want to follow along with us in your book. It might just be easier to see some of the problems from there. A couple of definitions before we begin. It says complementary angles are two angles that add up to be 90 degrees. And supplementary angles are two angles that will add up to be 180 degrees. We're going to see some examples using that in just a little bit. And we also need to know that all three angles inside a triangle will add up to be 180 degrees. So that's some important notes for this week. All right. So like I said, this is the end of the chapter review. I've got some exercises because we've got several shapes that we're going to be looking at and finding a lot of different things involving these. I'll try to zoom in as best I can when we get to some of these. This didn't copy very well for me, so I did have to trace over some of these, so you'll see my own handwriting on this copy, but that's page 581 and 582 if you want to follow along. So the first one says the diameter of a sphere is 1.5 meters. Find the radius of a sphere. All right, so first of all, to remind yourself that a sphere is like a three-dimensional round object, like a basketball, baseball, the world, a globe, okay? So I'm just going to take a look at a circle for just a moment. A diameter will cross through the center of a circle, and its endpoints will be on the circle. So that's the distance across the circle, and it says the diameter of a sphere is 1.5 meters. Okay, so we're looking for the radius, but the radius is half the length of the diameter. So the radius is half the diameter, or the diameter is twice as much as the radius, however you want to think about that. But if I know the full diameter, I'm just going to take 1.5 and divide it by 2 to find out what that radius is, and that would be 0.75 or 75 hundredths of a meter. Okay. All right, so we need to understand what diameter and radius are because we're going to use those values finding things like circumference and area of a circle. So number 2 asks us to find the circumference of a circle that has a radius of 5 centimeters. Use 3.14 for pi. So in a circle, circumference is the distance around that circle. Any other shape, we would call that the perimeter, but for a circle, that's called the circumference. We are given that the radius is 5, okay? So there's two formulas that we can look at, but they mean the same thing. Circumference is pi times diameter, or 2 pi r, okay? And we can use either one of those because one diameter is the same as 2 radii, okay? Plural for radius. So I am given a radius of 5. It says in the place of pi, because pi is an irrational number, it goes on forever without an end, we use the approximate value of 3.14. So I'm going to multiply 3.14 times the diameter, which is 2 times the radius, that would be 10, and that's going to equal 31.4, and my label is centimeters. So a lot of this week is just understanding the information that you're given regarding these shapes, and then using that information, substituting it into the correct formula, performing the correct operations to get your answer. I don't expect you to have memorized or even remember every formula, but you can find those in your textbook. You can look them up online. They're all available to you, whatever shape you're looking for. Number 3, we're asked to find the perimeter of the rectangle. Perimeter is the distance around, okay? So we're just going to add up all the sides. I'm given that one side is 8, one side is 5. This is label as feet, okay? We know that in a rectangle, opposite sides are equal to each other. So we're just adding 8 plus 5 plus 8 plus 5. And that would be 13 plus 13, which equals 26 feet in the end. All right. I want you to notice as we go, I'm going to try to point this out. When we're calculating perimeter or circumference, which is the perimeter of a circle, my label will just be whatever unit I'm working with, okay? So circumference and perimeter is just going to be that unit of measure. I'm going to jump on down to number 10 because I want you to take a look at another one that involves area. We'll do 10 and 12 before we go back to those others. When I'm calculating the area of something, I want to know the space on the inside, okay? So when I'm looking for the area of this circle, I want to know how much space is taken up on the inside of that circle. The formula for the area of a circle is pi r squared, okay? So we have to know the radius. There's no other formula to work with here. So it's radius squared, radius times itself, and then times 3.14. So that's important to use order of operations as we work through here. Now in this problem, we're given the diameter is 9, but remember the radius is half of 9. Be careful, half of 9 is not 3, but half of 9 is 4.5. So I'm gonna make the substitutions, use 3.14 in the place of pi. So 3.14 times 4.5 squared. Okay, you can use your calculator, but the way you work this problem is important. We have to do exponents before we multiply. So that's 4.5 times 4.5 times 3.14. And multiplying those all together, we're going to get 63.585, okay? Unless it asks you to round, this went out that far, so I'm just showing all decimal places, but be careful. A problem might ask you to round to the nearest whole, square centimeter, so to be able to round properly whatever place value it asks. Okay, so now the label. When I'm calculating area, because technically what I did was not just square 4.5, but I'm squaring 4.5 centimeter. 4.5 centimeter times 4.5 centimeter, and what that does is give me a square unit of measure. So anytime we're calculating area, your label will be square units, okay? You do not square the number, not this answer, but you're squaring the label. You can spell that out, square centimeters. If you use the exponent, remember that caret key we called that is how we indicate that we're doing an exponent. Or you can spell it out square centimeters. I'm fine with that, but just make sure to label that properly. So here's another one, the area of a rectangle. I want to know what is the space on the inside. The area of a rectangle is length times width, or base times height. We can use either of those for a rectangle. So I'm going to multiply 5 times 11. 5 meters times 11 meters would be 55 square meters. So watch that label again. Area is always square units, whereas centimeter and perimeter are just single units of measure. Okay. We jump to number 5 when we're talking about labels. Number 5 asks me to find the volume of a rectangular solid. The formula for finding the volume of a rectangular solid is length times width times height. Okay, I'm multiplying all 3 dimensions together. This is 4 feet times 5 feet times 10 feet. So I multiply 4 times 5 times 10. Of course, multiplication is commutative, so it doesn't really matter what order you multiply. Every number is getting multiplied together. 20 times 10, that would be 200, but it's feet times feet times feet, so we call that cubic feet, feet to the 3rd power. Once again, I'm not cubing 200, I'm cubing the label, so you can label that cubic feet, or you can use the exponent feature there for volume of a rectangular solid. All right, let me back up to number 4. We have a line L and 4 given points on that line. we're told that the length from A to B is 15, from C to D is 6. The entire length from A to D is 4. And the question asks, how much is this little section BC? So if we know the whole length, I can subtract the two amounts that I know, and that should give me my leftovers here. So essentially I'm going to say 24 minus 15 minus 6. And what will be left over is 3 units. There's no label here, so we'll just call that units. All right, number 6, we have a right triangle. I know this is a right triangle because this symbol right here indicates it, okay? A right triangle has one angle that is 90 degrees, okay? That's important to know. When you have a right triangle, then the Pythagorean theorem works to help us find a missing side of that right triangle. A squared, B squared equals C squared, okay? A and B are the legs of your right triangle. Those are the sides that make up that 90-degree angle, okay? It does not matter which side you label A and which side you label B. Those do not matter. But C is the hypotenuse. It is always the side opposite that 90-degree angle. So it's always the longest side of the triangle. It will always be the biggest number of the three. So what we will do is substitute the numbers we're given into the formula and find the side, okay? So 10 squared plus 24 squared equals C squared. So we'll perform the operations. 10 squared is 10 times 10, okay? 24 squared is 24 times 24. Okay. So that would be 100 plus 576 equals 676. All right. Now we want to be careful that we don't stop too early. What I have calculated is C squared, but I want to know what C is. So to undo a square, we have to take the square root of both sides, okay? So the square root of 676, and you should have a feature like that on your calculator, the square root of 676 is 26. C equals 26, and that is centimeters. 10 squared plus 24 squared is the same as 26 squared. That's what the Pythagorean theorem says. Now, in this problem, we were missing C, so we squared our numbers and added them together. And then we took the square root. While we're talking about the Pythagorean theorem, I'm going to work another one on the next page. If you're just joining us, I'm looking at the end of chapter 12 problems on page 581 and 582 from your textbook. If you'd like to follow along there, you can. I'll come back to this page. But I want to hit number 19. Okay, this is a word problem, but it's related to the one we did. So it says, how high on a building will a 17-foot ladder reach when the bottom of the ladder is 8 feet from the building? Okay, so we might need to illustrate what this problem is talking about. Okay, so we have a building. All right, here's my building. A ladder is propped up against the side of that building. We know that the ladder is a 17-foot ladder, and we also know that the base of that ladder is 8 feet from the building. Okay, so this is what we know. Do you see that what's created right here is a right triangle? And the question is, how high up that building does the ladder go? So I'm going to put an X there for my unknown. So because I have a right triangle and I'm missing one side, we can go back to the Pythagorean theorem, substitute the information we know so we can solve for the missing information. But what's very important here, this one's going to be worked a little bit different because I'm not missing the hypotenuse, okay? C is 17. I'm missing one of the legs. It does not matter which one you label A or which one you label B. That's not a big deal. But as I substitute these numbers in the problem, x squared plus 8 squared equals 17 squared. Okay, I'm going to have to work through these operations and solve this to find x. Okay, so in the last one, I was missing C. We squared our numbers and added them together. Okay, here I'm going to square my numbers, but I'm going to be subtracting them to find this missing number. So x squared plus 8 times 8 is 64. 17 squared is 289. 17 times 17 is 289. You know, this is an equation like what we practiced last week. I'm going to subtract 64 on both sides. X squared equals 225. But I don't want to know what x squared is. I want to know just what is x. So that final step is take the square root of both sides. So the square root of 225, I'm just typing that in my calculator, is 15. Okay, so that ladder will reach 15 feet up that building wall. So illustrate it with a picture so you can understand where all those numbers are located. Decide what is your A, B, and C. C has to be across from that right angle. That's my hypotenuse. Plug in your information and solve for what's missing. Sometimes you square and add. Sometimes you square and subtract. So be careful. When you're looking for a leg, you square the numbers and subtract them. But either way, your last step is to take the square root. Okay, I'm going to go back to the previous page. Number 7 says find the supplement of a 105-degree angle. We just looked over that definition at the beginning. Supplementary angles add up to be 180 degrees. So if I want to find the supplement to 105 degrees, I need to know what angle can I add to 105 degrees to equal 180. So all we have to do is subtract 180 minus 105. That will be 75 degrees. Okay. I'm not sure. I'm sure in your symbols in Excel that there will be a degree symbol. If you're having trouble with that, then just spell it out. Degree. Okay. No big deal. Okay, number 8 is find the square root of 15, and this time we're going to round to the nearest thousandth place. The square root of 15 is not a perfect square. Okay, so let me type that in. Let's take a look at the decimal here. All right, so when I type that in, this is an irrational number. That decimal is going to go on forever with that end. The thousandth place is the third position after the decimal, tenths, hundredths, thousandths. But remember, in rounding, we have to look at the very next number. I need to know what that fourth number is to decide, will it stay a 2 or become a 3? 5 or more, bump up the score. So that's going to be approximately 3.873. So just read the directions to see what position you're rounding to and watch those rounding rules. Okay, number 9, we have 2 triangles, triangle ABC, triangle DEF. It says that they're similar, and we want to find the height of this second triangle. All right, so here's what we know about similar triangles. Corresponding angles are equal to each other, and side lengths are proportional. Okay, now we're not given any angles. We do not know what A, B, and C are, nor do we know what D, E, and F are. But we do know that A and D are the same, whatever they are. If A was 30 degrees, then D would be 30 degrees. Okay, B and E would be the same. degree measure, and C and F would be the same degree measure. Corresponding angles are congruent. They're equal to each other. Okay. Corresponding side lengths are proportional. So like AB would not be the same as DE, okay, but that ratio would be the same ratio as BC over EF, whatever that would be, okay? And the same would have to be true for the heights of those triangles. So what I'm gonna do is set up a proportion and solve this. There's several ways I could set it up, but I'm just gonna start with the first triangle and go to the second triangle. I'm gonna take height over side, so 8 over 12, and set the second one up as height over side, using those corresponding measures. Height over side equals height over side. Because corresponding angles are, corresponding side lengths are proportional, I can do that. Obviously, you could cross multiply like we've learned. This one will be a little easier to do mentally because I know that 12 times 2 is 24. 8 times 2 would be 16. That would have the same label, 16 centimeters. Remember, if we were cross multiplying, it would be 8 times 24, and then divide that by 12, and I would still get that same answer. I'm going to jump to number 16 because it's very similar to that, but 16 asks for an extra question that goes along with it. This is really similar to that. We have triangles ABC and DEF. It says they're similar, so those same rules apply. But I'm not just finding a missing side. It asks me to find the area of triangle DEF. Remember, area is the space on the inside. Now, here's what you need to know about the area of a triangle. Excuse me. The area of a triangle is 1/2 base times height, or base times height divided by 2. Either version of that, it's the same thing. Notice I know what the height is, but I do not know what the base is. I'm going to call that X. I do not know what the base is. I have to find that base, okay, so that I can use it in this formula. Because they're similar, corresponding side lengths are proportional. So I'm going to take height over base, 5 over 8, and set it up as height over base here, 9 over X, because their ratios are equal to each other. I can find this by solving the proportion. I'm going to need to cross multiply this time. 5 times X will equal 8 times 9. Remember, we divide by the number in front of the variable. 72 divided by 5 is 14.4, okay? That is not the answer to this question, so don't stop too early. That is just what the base is. Okay, remember that the actual question was find the area. So I'm going to consider my formula. The area of triangle DEF is base times height divided by 2. Okay, so in my calculator, 14.4 times 9, divide that answer by 2, we're going to get 64.8. Area is always square units. Okay, so meters squared, square meters. I'm going to jump back to the previous page here. Take a look at number 11. We have 2 lines, line 1 and line 2. This symbol says they're parallel. That means they're never going to cross each other. But we do see that they are cut by a transversal. This line T intersects both line L and line 2. And when that happens, notice there are a lot of angles that are formed, okay? So lots of things that we could talk about here. But ultimately, to help you on a problem like this, you need to know that all of the acute angles are going to be equal to each other. All of the obtuse angles are going to be equal to each other, okay? So an acute angle is an angle smaller than 90 degrees. An obtuse angle is an angle larger than 90 degrees. So all of the acute angles are equal. Notice that we are only told that this is 45 degrees, okay? So every acute angle in this problem will be 45 degrees. This is 45 degrees, this is 45 degrees, and this angle right here is 45 degrees, okay? We already know all of those. Now, what I've just found here is B, angle B, which was question A. Angle B is 45 degrees. Okay, now I can use the fact that this is 45 degrees to find A, because these two angles are side by side. They're called adjacent, and adjacent angles are supplementary. That means they add up to be 180 degrees. So if I subtract 45 from 180 degrees, I'm going to get 135 degrees. So that means every obtuse angle is 135 degrees. I didn't have to find every angle, but just knowing one, I can find all of them, okay? One thing I want you to be careful about, and I don't know if it says it the same way in your apply, but notice part A asked for angle B, part B asked for angle A. So just watch how that question is presented to you and make sure you answer each correctly. Okay, we're gonna move into some composite figures. This, sometimes might be the most difficult part of our lesson this week. We're not just talking about one shape, we're putting several shapes together. Okay. All right, I'll start with number 13. It says, find the volume of the composite figure shown below. There is no formula for this shape itself, but depending on where we draw the line, maybe here, I could draw a line here, or here. Do you see that that is like two boxes, either one stacked on another one or two stacked side by side? Okay, I'm going to draw the line here. So we've already learned that the volume of a rectangular prism is length times width times height. So what we got to do is just be careful to use the correct number in the right spot. Let's begin with this bottom one here, okay? I've got length, width, and height, okay? So I'm going to multiply 7 times 8 times 3. 7 times 8 times 3. Okay, that's going to be, this box right here is going to be 168, and that's cubic inches. Now I need to find the top, okay? But I've got to use the correct numbers. I can't just make up what goes where. Now I know this little part is 3. This section is 8, so everything opposite, that side is going to be 8 all the way up. This whole thing is 6, and this little bitty part is 3, so that means this section up here must be 3 as well. So I've got length, width, and height right here in these three numbers. 3 times 3 times 8, that's going to be 72, and that's also cubic inches. So to find the full volume of this composite figure, we're going to add those numbers together. 72 plus 168 will be a total volume of 240 cubic inches. All right, so that's the thing about composite figures. You've got maybe two different shapes that you're putting together to make a new shape. So we have to break them into shapes that we can calculate with our formulas, and then in this case, we combine those together. Now, I know that you're probably going to have to rewatch this video later because some of this information is just, it's too much to just consume in 2 minutes, So I have tried to provide examples like what you're going to see this week. So take the time to look back over these, at least the individual problems that you need to help you through this week. All right, number 14, we're finding the area of the composite figure. Use 3.14 for pi. Remember, area is the space on the inside. There is no formula for this shape right here, okay? But if you look at it, it is a rectangle and half of a circle. We call that a semicircle. It's like a circle cut in half. So I need to find the area of the rectangle, the area of a circle, and cut that one in half, and then combine those two together. The area of a rectangle, that's easy. Length times width. That would be 32 square inches, okay? Area of a circle, you know, a little bit more complicated. That is pi r squared. So remember, I'm given the diameter is 8, but radius is half of the diameter. So 8 divided by 2 would be 4. I'm going to use 3.14 for pi. R is 4, and I'm going to square it. That's going to give me the area of a full circle. So I'm going to have to divide that in half to get the semicircle. Remember, with our order of operations, I have to square the 4 first, okay? So it's 4 times 4 times 3.14 divided by 2. And that's going to equal 25.12 square inches, okay? So I've got 2 individual areas that I'm going to add together to get the total, which is going to be 57.12 square inches. Remember, area is square units, volume is cubic units. I'm going to do one more composite figure, number 17. This one asked me to find the perimeter. Remember, perimeter is the distance around a shape, okay? Distance around it. And to find that, add up all the sides. I know these 2 sides, but I don't know this curve, okay? Remember, the distance around a circle is called the circumference. Circumference equals pi times diameter, and we're going to use 3.14 for pi. So 3.14 times the diameter of 10 would get me the circumference of a full circle. But since this is a semicircle, I'm just going to divide that in half, divide it by 2. So 3.14 times 10 divided by 2, that would be 15.7. And then we have to add that with 16 plus 16 all the way around perimeter. And that gives us a total of 47.7 inches. Volume is cubic, area is squared, but perimeter is just that single unit of measure. All right, we're gonna, I better go back to one more. You might have a question related to the volume of a sphere. So let me give you that formula in case you need that. Volume of a sphere is 4/3 times pi r cubed. Remember, a sphere is like a basketball, a baseball. So it's 3-dimensional circle object here. To find the volume of that, we'll use this formula. 3.14 is pi. The diameter of that sphere, sphere here, the diameter of that is 8. So the radius is half of that, which is 4. Okay. So I'm just plugging all that into my formula. 4/3 times 3.14 times 4 cubed, because remember, volume is always cubic units. 4 to the third power is 4 times 4 times 4, okay? Times 3.14 times 4 divided by 3, you know, or you can do 4 divided by 3 times 3.14 times 4 times 4 times 4. But the main thing is, do not multiply these three numbers before you cube it. Only the 4 is being raised to the third power. And then this is all multiplication. So that final answer is going to be, let me actually do, this one we're going to need to round to the nearest tenth. So I'm going to type this quickly in my calculator. 4 thirds times 3.14 times 4 to the third power. My calculator actually has exponent button. I'm not sure if yours does. But so here's this decimal. Rounding it to the nearest tenth place is this 9. But I look right behind it, 4 or less, let it rest. So this is going to be 267.9. That's feet, and we're going to cube it, cubic feet. Remember, you can spell that out if you have trouble finding the exponent key. All right, we're going to spend the rest of our time going over some word problems. So I'm going to skim on down here to number 20. Says a right triangle has a 32-degree angle. Find the measures of the two angles. We're going to have two answers on our paper here. Now, I could not find these answers if I only knew one angle, okay? And it looks like that's all they've given us, but they've really told us more. They've told us this is a right triangle. So that means one of my angles is 90 degrees. I already know one of those answers, okay? And I told you at the beginning of the lesson tonight that all three angles inside of a triangle will add up to be 180 degrees. So now I just need to add these two together, subtract that from 180, and I'll find my third angle. So 90 plus 32 is 122, and then we'll subtract that from 180. So my last missing angle is 58 degrees. But please do not miss the fact that this question has two answers. The other two angles, 90 degrees, and then my third angle is 58 degrees. All three have to add up to be 90 degrees. Number 21 says a bicycle tire has a diameter of 28 inches. That's illustrated here. How many feet does the bicycle travel when the wheel makes 10 revolutions? That is 10 turns. Okay, notice that's the distance around that tire. That's the circumference, okay? So I've got to calculate that 10 times. Use 3.14 for pi and round to the nearest tenth of a foot. And here's what you got to be watchful for. This information is given in inches, but the answer has to be given in feet. So we're going to have to do some converting in just a little bit. I'm going to work this out with the information given to me, and then we can use a unit multiplier to convert this in just a second. So the diameter is 28 inches. If I could find the circumference of that tire, okay, and then multiply it by 10, I would see how many inches that wheel travels. So circumference is pi times diameter. That's 3.14 times 28 is 87.92. That's just one turn. We're going to do this 10 times. So that gives me 879.2 inches. Okay, but remember, I need an answer in feet. So now we've got to convert. And this is what we were doing a good bit in previous chapters. Remember, 12 inches in 1 foot. Okay, that's my unit multiplier, so I can cancel those. 879.2, we're going to divide that by 12. 9.2 divided by 12. Just flash that decimal here. We're rounding to the nearest tenth. Okay, so that 6 will bump up the score. That's going to be 73.3 feet. And it's just circumference, so single unit of measure there. All right, I'm going to do 2 more. If you're watching this later, our code word tonight is geometry. You can email me a brief summary of our video and include the code word geometry for your extra credit. Okay, it says use the information in the news clipping at the right. So here we go. A dive show at the aquarium. Visitors to the window of Washington Waters exhibit at the Seattle Aquarium can choose from 3 daily dive shows. Divers in the 120,000-gallon tank talk to visitors through a 40-foot by 20-foot rectangular acrylic window that is 12.5 inches thick. So that's telling us, they're describing that glass to us there. All right, so inside and out, what is the total area of window that must be cleaned? Okay, so inside and out. So that means if I clean the outside of the mirror and then again on the inside of that mirror. Remember, area is length times width. It was a 40-foot by 20-foot window. So area is 40 times 20, which is going to be 800, but that's just one side, right? So I'm going to double it because I've got to clean both sides, and that will be 1,600. Remember, area is square feet. Hope you can, I'm squeezing that in there. I hope you can see that answer. 1,600 square feet. Now B asks for volume. Remember, this glass has a thickness, okay? So it's got a thickness to it. Volume is length times width times height. What volume in cubic inches does the window in the exhibit fill? All right, so here's what we've got to be careful about. My question wants an inches answer. The thickness is given in inches, but the length and width here are in feet. Remember, one foot is 12 inches. So if I have 40 feet, I'm going to multiply that times 12, and I'll take this 20 times 12, 20 times 12, 40 times 12. So that's going to actually become 240 inches and 480 inches. And don't forget the thickness there. That's where we get that third dimension. So I'm going to take length, width, height. I'm saying those, but I'm definitely not putting those numbers in the right order. But multiplication is commutative, so it doesn't really matter. So length in inches, height in inches, width in inches, and we're multiplying those together. So 240 times 480 times 12.5. It's a big number there. That's 1,440,000. That's cubic inches. $1 million. All right. Last question here we're going to go over tonight. A silo in the shape of a cylinder. Okay, so a cylinder, think like a can, is 9 feet in diameter and has a height of 18 feet. What is the volume of this silo? Okay, so in this shape, the cylinder, to calculate the volume of it, you're going to have to find the area of the base and multiply that times the height of that shape. Okay, it's not a neat little formula like the others that we've looked at. Okay, notice the bases of this cylinder are circles. I've got to find the area of a circle, that's the base, and multiply it times the height. Area of a circle is pi r squared. I know the diameter is 9. Half of 9 would be 4.5. Okay, that's r, half of 9. So I've got 3.14 times 4.5 squared. That's the area of this circular base. Okay. So area of the base, 3.14 times 4.5 times 4.5. Multiply all that together and then multiply it times the height of 18. And that's going to give me 1,144.53. We are in feet. This is volume, so cubic feet. Sorry, I don't have a lot of space here to show all my work, but take your time, look at those formulas. If there's some formulas you're not familiar with, you can look those up online. Your textbook, I'm sure, has all of those available to you as you need. Remember, odd answers are generally in the back of the book, so if you need to work a few extra problems and check yourself, you may do that. Please reach out to me this week if you've got questions leading up to the apply, the post-test, and our final exam.